Have you ever wondered how machines can learn on their own? As we delve into the magic of self-learning machines, imagine physical devices that can process information and learn from data. It's quite the marvel, isn't it? Now let's introduce a groundbreaking method of birthing these machines. Here's how it works. The information processing and learning parameters are encoded in the degrees of freedom of a time-reversible physical system. In simpler terms, the machine's ability to learn and process information is tucked away in the flexibility of a system where time is no barrier. This innovative approach enables these machines to autonomously update their learning parameters, making them more efficient and independent, just like a student picking up a new language or a musician mastering a new instrument. These machines learn by updating their knowledge base, and the best part, this method isn't exclusive to a specific type of machine. It's universal, paving the way for a myriad of self-learning machines across various physical systems. That's right, machines are taking learning into their own hands, or should we say their own gears. So how do these machines actually learn, you might wonder? Well, it's a fascinating process that relies on an efficient training method based on time reversal operations. This unique approach allows for the autonomous update of the physical learning parameters. It's a bit like teaching a child to ride a bike, but instead of our knees getting scraped, these machines adjust their learning parameters autonomously. Now, what makes this method truly remarkable is its universality. It can be applied to a vast array of physical systems. Imagine a world where all sorts of machines, from your coffee maker to your car, are learning and improving their functions on their own. It's not science fiction, it's science fact. To illustrate this point, let's consider self-learning machines based on coupled non-linear wave fields. These machines are like a symphony orchestra where each instrument, or in this case wave field, plays its part. Yet they're all interconnected, learning and adjusting based on the data they process. It's a harmonious dance of learning and adaptation that continually refines the performance of the machine. This process, known as Hamiltonian echo backpropagation, involves injecting a small error signal on top of the echo dynamics to update the learning parameters. It's like a feedback loop where the machine learns from its mistakes and adjusts accordingly, becoming smarter and more efficient with each iteration. In other words, these machines are schooling themselves in a way we never thought possible. Now let's delve a bit deeper into the science behind this fascinating concept. At the core of self-learning machines, we find something known as Hamiltonian echo backpropagation. It might sound like a mouthful, but fear not, we'll break it down. This method is akin to teaching a child to ride a bike. The child might falter at first, but with each stumble they learn a little more about balance and control. Similarly, Hamiltonian echo backpropagation involves injecting a small error signal on top of the echo dynamics. This error is then used to fine-tune the learning parameters, allowing the machine to learn and adapt. Now, what about pseudo-dissipation via ancillary modes? Imagine a ship sailing through a storm. The ship, our machine, uses the ancillary modes, the waves, to navigate the storm. These modes help the machine process information more efficiently, leading to better performance. And finally, the architecture of self-learning machines. There isn't a one-size-fits-all blueprint here. Different machines will have different architectures based on their specific tasks and environments. This flexibility allows for the creation of a wide range of self-learning machines, each unique in their own way. So the next time you see a machine, remember it might just be smarter than you think. So, what does this mean for the future of machines and indeed our world? Well, the implications of this research are vast and far-reaching. Self-learning machines could revolutionize numerous fields, from healthcare and manufacturing to entertainment and education. Imagine machines that can diagnose diseases with greater accuracy, or production lines that can independently optimize for efficiency and quality. But let's not stop there. Consider interactive entertainment systems that learn and adapt to provide a truly personalized experience, or educational platforms that can tailor learning to each individual student's needs. But what truly sets this approach apart is its autonomy. No longer will these machines require constant human input to learn and adapt. Instead, they will be able to independently update their learning parameters based on the data they process. This autonomy could lead to a paradigm shift in how we view and interact with technology. Of course, with such potential comes responsibility. We must ensure these self-learning machines are used ethically and for the betterment of society. The future of machines is not just smart, it's self-learning. It's a brave new world on the horizon. To continuously be enlightened, like and subscribe.